Hello, good day to all my Form 5 students. Today we are here to continue on the chapter Thermochemistry Part 2. In Thermochemistry Part 1 of my lesson video, I have explained about the important concepts and terms involving endothermic and exothermic reaction, how to differentiate between endothermic and exothermic reaction, and also how to make sure a certain reaction, chemical reaction especially, is endothermic and exothermic using the concept breaking and forming the bond. I have also given few important examples for endothermic and exothermic reaction. Now, in this part 2 of our thermochemistry video, we will continue to discuss on type of reaction or heat of reaction which produces either endothermic or exothermic reaction, and we will concentrate on how to calculate thermochemistry reaction or thermochemistry reaction for a certain reaction that you have already learned. Now let's start. What is the meaning of heat of reaction? Heat of reaction is the heat absorbed or heat released during a chemical reaction. Teacher repeat, heat of reaction is absorbed, heat absorbed, endothermic or heat released during chemical reaction. So, the term heat absorbed or heat release will determine whether this reaction is an endothermic or exothermic reaction. Now, before we go further, teacher would like to explain to students that the four type of reaction that we are going to deal with in this chapter. Now, please don't worry. All the reactants or all the reaction that you are going to learn or we are going to discuss in this chapter are those that you are familiar with. Alright? For instance, what are the type of reaction that we are going to discuss in thermochemistry chapter is heat of displacement. We have learned this in chapter 1 of your Form 5 syllabus. Heat of precipitation. We have learned in your Form 4 chapter. Heat of neutralization. Another chapter in Form 4. And heat of combustion. We have learned this in your Form 5 carbon compound chapter. So please remember that all the reactions that teacher going to discuss here from thermochemistry point of view are nothing new. Alright. Now let's go to today. I am going to discuss heat of displacement, the first type of reaction from thermochemistry point of view. Now, students, please try to remember what is displacement. Displacement is a process or a chemical reaction where a more electropositive metal displaces a less electropositive metal ion from the salt solution. Teacher repeat, displacement is a chemical reaction where a more electropositive metal, a more reactive metal, displaces a less reactive metal ion from the salt solution. Now, I know you are aware about displacement of metal, but now we are going to discuss about displacement of metal from thermochemistry point of view. Now, if we want to explain about heat of displacement using thermochemistry point of view, this is how we explain or define heat of displacement. Now, extra that teacher has added here is heat of displacement, not displacement reaction. Now, heat of displacement. So, what are the concepts and terms that differ here? Now, I would like to highlight, can students see the word heat change? That means technically you are going to deal with either exothermic or endothermic reaction. So that is the reason why it is crucial for students to watch my part 1 of thermochemistry video. Right? Okay, so heat change either exothermic or endothermic, and when 1 mole, now can you see this is the difference here? 1 mole. So I hope students can remember why when I was explaining about endothermic and exothermic with its unit, I was using the term kilojoule per mole. So I hope students can understand. Now we are going to look at heat of displacement using thermochemistry point of view, which is heat change, and we will be technically discussing in 1 mole point of view. So that is the reason why the unit for any type of reaction will be kilojoule per mole. Right? Okay, now so for heat of displacement, the general term for heat of displacement will be heat change when 1 mole of metal is displaced from its salt ion or salt solution. Student can write here from salt ion or salt solution, and students can even add by a more electropositive metal. Okay, so I hope students can write this down. Huh? Okay, so now what happens is important that I want students to know is heat change, and 1 mole is crucial for us to discuss heat of displacement in thermochemistry point of view. Now let's look at one example of energy profile diagram for example of an heat of displacement. Now please remember explained about energy profile diagram of endothermic and exothermic reaction in part 1 of our video. So I think should be okay that students I explained this from starting from heat of displacement. Okay, now the students look at magnesium argentum nitrate, magnesium nitrate, argentum. Now this is an energy profile diagram for a displacement of argentum ion by a more electropositive magnesium metal, and the heat release. Mark my word, teacher confidently used the word heat released because heat released involved exothermic reaction, and please look at the sign. Exothermic reaction always brings negative sign. So, what teacher forgot to explain in part 1 was how to write thermochemical equation. Now, let's do this thermochemical equation according to the energy profile diagram that I have written here. Alright, so this is how you write chemical equation. Alright, now this is how you write chemical equation. Magnesium with 2 argentum nitrate, 2 mole of argentum nitrate, magnesium nitrate plus argentum. Okay, or if I want to write this in ionic equation form, it will be magnesium plus 2 argentum ion produces magnesium ion and 2 argentum. Now, please remember this is chemical equation. This is ionic equation. There's nothing new about it. But when teacher add this information, or you can use for either one, doesn't matter. This changes into thermochemical equation. This means you are adding information about the amount of heat energy involved, and the negative sign shows that this is obviously an exothermic reaction where the total energy content of the reactant is higher than the total energy content of the product. Teacher repeat, the total energy content of the reactants in exothermic reaction is always higher than the total energy content of the product. So this obviously shows exothermic reaction. Now please remember, negative sign shows exothermic reaction. Positive sign shows endothermic reaction. Right? Okay, now so without further ado, let's move on to one example on how to calculate thermochemical equation. Okay, how to calculate thermochemical heat energy for a reaction and how to produce a thermochemical equation together with how to draw energy level diagram for a particular reaction. So I hope students understand we have almost important 6 to 7 steps for this reaction. Alright, okay, so let's start. When 25 cm cube 1.0 mole per dm cube of copper 2 nitrate. Okay, so copper 2 nitrate is displaced by 10 gram of zinc. Now students, please understand, you must make sure whether this reaction happens or not. Copper 2 nitrate is going to be displaced by zinc. Now the first question, does this happen? Yes. Why? Copper is less electropositive than zinc. Teacher repeat, copper is less electropositive than zinc. Thus, zinc can displace copper ion from the salt solution. So, indeed, this reaction happens. Now, let's read further. So, allow me to underline the important information that needed. Alright? Okay, now, so usually 10 gram of zinc, teacher will not take it into consideration. Why? Because please remember that this 10 gram of zinc might be an excess. We don't know. But why am I taking this into consideration? Is because I hope students understand in chapter 7. Okay, in chapter 7 of your Form 4 syllabus, we have studied about standard solution. So standard solution is always the most accurate. So when I have the choice to choose between metal, solid, okay, mass of a solid with a standard solution, I will always choose a standard solution. Alright, calculate the mole. Alright, okay, now displaced with 10 gram of zinc, the temperature. Here is the another crucial information. Okay, so these two are the crucial information. Temperature rises. Now students, the word rises is more than enough to show you all that this is an exothermic reaction. What have I told you regarding exothermic? Temperature increases, rises, temperature of the surrounding increases, heat energy released. Alright? Okay, heat energy released, okay, and all that. Okay, now, so these are the steps that students need to write down in order to calculate the thermochemical equation. Okay, calculate the heat of reaction and thus write the thermochemical equation. Now, let's go to step 1. Okay, allow me to rub this off. Allow me to rub this off. Okay, allow me to rub this off. Okay, you have to watch this video few times in order to get the hang of it. Okay, so students, please watch my lesson video few times in order to understand the concepts. Alright, okay, now so let's go to step 1. Okay, step 1, you have to write chemical equation, which is zinc added with copper 2 nitrate to produce zinc nitrate. Okay, zinc nitrate plus copper. Now, number 2, they are asking for ionic equation. So, ionic equation is written based on the ions which have changed their oxidation number. Please remember, ionic equation is written based on the change on their oxidation number. So, if you can remember chapter 1 of our Form 5 syllabus, you will know zinc will change the oxidation number. Copper 2 ion will change its oxidation number. Okay, but nitrate ion won't change its oxidation number. Thus, nitrate ion is eliminated when writing ionic equation. So, please go back to my chapter 1 videos on how to produce ionic equations. Okay, now, so let's move on to number 3. Calculate the mole of copper 2 ion and also the theta. Theta is actually the change in temperature which has been already given for students here, 10 degrees Celsius. Alright, okay, so let's go to number 3. So number 3, now please remember standard solution. How are you going to find the mole of standard solution? You might be thinking why mole came into the picture. Please go back to the general term of heat of displacement. Can you see one mole is involved already? So that is the reason why you have to calculate one mole, like it or not, right? Okay, now so teacher will always take, I prefer to take the standard solution for calculation of mole, okay, which is mole copper 2 ion will be mv over 1000. These are all the concepts that you have learned in Form 4. Alright? Okay, so it will be volume 25 times the molarity 1 divided with 1000. So you will get divide 1000. So students will get 0.025 mole. Okay, 0.025 mole and theta, that means the rise in temperature. They have already given you the rise in temperature is 10 degree Celsius. Now let's go to number 4. This is what I would like to explain to students. Now, what is a new term? We have a new term called energy change. MC theta. M comes from the volume of the substance. Now, volume, now please remember, here we don't take zinc into consideration. Why? Because zinc is a solid. Second is in order to produce ion, zinc metal will eventually dissolve. Okay, in order to ionize, it will dissolve in the solution. So that is the reason why for mass we don't take the mass of zinc as the consideration. So students, please don't make the mistake of 25 cm cube added with 10 gram. Unit also wrong, technically, conceptually also wrong. Why dissolves? Zinc dissolves in solution, the copper to nitrate solution. So mass of zinc cannot be taken into consideration. Now let's go to MC theta. Teacher write properly. So MC theta. The next question for students will be, teacher, how am I mass? Now it is combining, because when teacher used the word mass, that's why teacher highlighting this. When teacher use the word mass, automatically all of you will look here. That's where you make the mistake, where I won't be surprised if students do this. They say 10 because they assume mass is 10 gram. No. Please remember, mass of zinc cannot be taken into consideration thanks to zinc able to dissolve in the solution. Right? Okay, so mass of copper to nitrate as a solution is taken into consideration. Now, the next question, how are we going to convert cm cube into gram? Because mass. Alright, now please remember, for water, 1 cm cube is is equivalent to 1 gram. Please remember density, 1 gram per cm cube. So density of water is 1 gram per cm cube. So this shows that 1 cm cube is equivalent to 1 gram. So that is the reason why 25 cm cube is equivalent to 25 gram. Okay, 25 gram, or if you want, teacher can write like this: 25 cm cube times the density of water, 1 gram per cm cube. So can you see, technically we cancel this out. Okay, technically we cancel this out. Okay, you cancel this out. So you will have only 25 gram. Right? Okay, now the next question. Where did the sea appear from? Students who are learning physics, they will understand that the sea is actually the heat content. Okay, so we call it heat content, heat energy content or something. Okay, heat energy content for the, yes, is the heat energy content for for solution. Okay, so which is going to be 4 joule per gram per Celsius. Okay, heat energy, I think this is a heat energy content. Okay, so that's how they see. So please look at the physics. Sorry, teacher can't explain much on this. Alright, okay, now so the C is actually the heat energy content for solution or liquid. So what happens is times 4.2 joule per gram per Celsius. Okay, and what is the theta? Theta, we already know theta is 10 degrees Celsius. So you times with 10 degrees Celsius. So please watch teacher's video a few times in order to understand how you end up with joule. Right? Okay, now, so 25, I think I've explained this. Okay, so eventually you are going to get 25 gram times, you see, Celsius, Celsius. So you cut off the Celsius, okay, you can cut off the gram, and you have 4.2 times 10 joule. Teacher repeat. I hope you can understand how I get this 25 cm cube convert into gram using density of water. 4.2 joule per gram per Celsius is the heat energy content for solution. Right? And the 10 degrees Celsius came from the question, which is 10 degrees Celsius. So when we add, when we times all of them together, you can see that eventually all the units get cut off by itself, leaving joule alone. Right? So leaving the joule alone. So the answer for this question, for this will be 1050 joule. So can you see? Calculate heat change. Heat, the unit is joule. So you get 1050 joule. This means for this particular reaction with the mole of 0.025, the heat produced is 1050 joule. Now let's go to the next question. Number 5. Determine the heat of displacement. Now to determine heat of displacement, I hope students can show this, which is 0.025 mole has managed to produce 1050 joule. Now, when I want 1 mole, how much heat will be produced? Students might be wondering, why am I highlighting 1 mole? Now, please look here. Can you see, we are not interested in 0.025 mole. We are interested in we are interested in 1 mole of metal ion. Teacher repeat, we are not interested in 0.025 of copper ion. We are interested in 1 mole of copper ion. So that is the reason why we do this calculation. So the answer will be 42000 joule or 442 kilojoule. Okay, so 42. Can you see 42 kilojoule? Why? Because I have divided with 1000. Teacher repeat. Let me calculate again. Okay, 42,000 joule divide with 1000. So students will get 42 kilojoule. Now, how are you going to determine heat of displacement? Now, please look at the way, concentrate on the way teacher writing. So, heat of displacement equals to negative 42 kilojoules per mole. Okay, now allow me to explain where suddenly the negative sign appeared. Negative sign is thanks to heat rises, shows exothermic. So that's why you know it's a negative sign. Kilojoule per mole is because you calculated according to 1 mole. So now I hope students understand. In my part 1 video, I was explaining kilojoule per mole in order to explain how a certain chemical reaction became exothermic or endothermic. Alright, okay, so this is how you write the heat of displacement. And students, you can even transfer this information to here. For instance, I transfer because it's basically the same ionic equation or chemical equation. Now, ionic equation, I'm transferring this information. Now, when teacher write this information, this automatically becomes thermochemical equation. Originally, it was an ionic equation. When I get the information about the heat of displacement, we can transfer this information to the ionic equation or chemical equation. You can even write here or write here. This automatically changes into thermochemical equation. Now let's go to the last part. Draw the energy level diagram. So teacher have explained how to draw. So first thing first, students must make sure you get the correct. Students, please make sure you get the correct shape of the graph. Since this is an exothermic reaction, it will be written or drawn this way. Okay, will be drawn this way. Where teachers sometimes prefer to write ionic equation. So, zinc plus copper 2 ion become zinc ion plus copper, and the heat energy released. Can you see teacher confidently using the word heat energy release? Why? Rises 10 degrees Celsius shows it is an exothermic reaction, and also a negative sign shows exothermic reaction. So you can transfer all the information that you have calculated to represent in an energy level diagram. So I hope students can understand what teacher have explained for heat of displacement, the meaning of heat of displacement, and also an example to calculate heat of displacement in a full package. Full package meaning starting from writing the chemical equation up to drawing the energy level diagram for this equation. So let's continue on thermochemistry chapter in part 3 of teacher's video. Till then, See you all of you. Take care.